The MCAT tests your understanding of the foundational concepts through 4 different scientific inquiry and reasoning skills. This video will provide an overview of those 4 skills and some ways in which questions can be presented. Why does it present the questions based on the scientific inquiry and reasoning skills? In order to be a physician in tomorrow, you can't just understand the knowledge of science. You have to understand how it's integrated with reasoning, with scientific inquiry, with research design, and many other things aside from just the content itself in terms of memory. The first skill that's tested is called the knowledge of scientific concepts and principles. There's going to be questions that are asking you to recognize, identify, recall, and define basic concepts and their relationships with one another. We will go over some examples in each section that these types of questions may be framed as. The concepts and principles are going to be represented by words, graphs, tables, diagrams, or formulas. So it may be in a familiar format, but it also may be in an unfamiliar format to make you have to recognize the connectedness between the concept and what you're presented. On the Chem Phys section, the first skill is going to be 35%, as well as on the Biochem section and on the Psych-Soc section. So when I say 35%, that is within 5%. So 30 to 40% of these 3 sections are going to be just questions based on your assessment of skill number 1. One example could be recognizing a principle from an example situation or study. So, for example, if they're talking about energy exchanges, do you recognize that the conservation of energy has to apply here in order to make one of these answer choices correct or incorrect? It also could be identifying a simple or familiar molecule. That's an example of an amino acid. So recognizing amino acids can be built up or broken down within the human body. So there are other molecules that contribute to breaking down amino acids or other molecules that amino acids get broken down into. But there are also other molecules that are needed in order to synthesize amino acids. So being able to recognize what pieces of an amino acid would be found in other molecules is also a way this question could be assessed, or this skill could be assessed. And for the Psych-Soc section, it could also be recognizing a condition that resulted in learned helplessness. So if they give you a specific person's experience and then they talk about outcomes of this experience, do you recognize that that was learned helplessness, and what about that person's experience was learned helplessness? Skill number 2 is based on scientific reasoning and problem solving. It's going to ask you to use scientific knowledge to solve problems, judge the credibility of other people's explanations of things, evaluating arguments about if this is causation versus correlation, so cause and effect, or whether or not it is cause and effect, identifying findings that question theories or models. So if you see something that was within an experiment and this finding that you found questions whatever theory or whatever model is presented, being able to identify why or which of those things would. The way those questions are going to be formatted, you're going to be looking at drawing conclusions from pictures or diagrams, also using formulas to solve problems, and figuring out which formula is needed to solve the problem. This is the most common type of question that you will see on any of the sections. So within 45%, again, within 5%, so 40 to 50% of the Chem Phys, Biochem, and Psych-Soc sections will all be based on your assessment of skill number 2. So this is very important to be able to understand some types of questions you may see based on skill number 2, recognize or identify a finding from a model, from a study that challenges or invalidates a theory or a model. So going back to, okay, well, we found this happened. Does this validate certain things? If we go back in just a history of science, okay, there was a certain scientific discovery that challenged whether or not the Earth was flat. And then we decided, okay, I guess the Earth isn't flat. And now there's a lot of provings that show the Earth is not actually flat. Same thing with the Earth being the center of the universe versus the sun being the center of the universe. being able to understand things that are challenging or invalidating theories or models, recognizing science can always be challenged and invalidated. Also, knowing a bond that would form between two structures if they were adjacent. So if you have two molecules or two different types of structures, amino acids, proteins, etc., that are next to one another, based on the structure of those molecules, what type of bond would be able to form? Is it a polar bond? Why would it be polar? What elements are within this bond that allow it for it to be polar? And anticipating what type of bond is forming there. Within psych-soc, predicting how an individual is reacting to cognitive dissonance. So this is based on, again, a given situation, being able to use what you have with you right now to infer a situation in the future. Skill number 3 is reasoning about the design and execution of research. So these are going to be important components of scientific methodology, how behavioral, natural, and social scientists conduct research, and how research tests and extends scientific knowledge. So this is all about, do you know how research works? Why we're doing research? Is this good research or bad research? Why is this good research or bad research? And how different types of scientists conduct their types of research. These questions are going to be assessing research design from formulating a hypothesis to making conclusions. So do you know how a good research design is structured? It's asking, can you figure out what assumptions were being made, what inferences were being made? Is there further research that can be done based on this research study? By each section, within 5%, so 5 to 15% of the chem, phys, biochem, and psych-soc sections will all be based on skill number 3. So it's far less than skills number 1 and 2, but it is still going to make up a part of each section that you will see, aside from the cars section. Some examples are going to be determining if a molecule is a product of two other molecules without rearrangement. So if you have an organic chemistry reaction and you have two reactants, can you figure out, will these reactants make this product? Why not? How could it not? Figuring out relationships among variables. So is this an independent variable? Is this a dependent variable? Why is one independent? Why is the other one dependent? Being able to understand why one is versus the other. Identifying ways to assess prejudice in a study on implicit bias. So recognizing there can be many ways to perform an assessment of something, figuring out which is best. Why is something best or most appropriate in a given circumstance? Whether things you're going to have to control from, whether the things you're going to have to be thinking about to prevent there being any problems with your conclusion. The last skill number 4, is database and statistical reasoning. So this is going to be all about demonstrating an understanding of the way scientists think about random systematic errors in experiments and data sets, and understanding of how scientists think about uncertainty, implications of uncertainty for statistical testing. So this is random and systematic errors, as well as uncertainty in your assessment of those types of data, and showing how they're using data to make comparisons between two variables or explain a relationship between two variables. So more than anything, you're going to have to read and interpret results using tables, graphs, and charts. You're also going to have to identify patterns in data, draw conclusions from evidence that you are given. Skill number 4 is similar to skill number 3, between 5 and 15% of the chem, phys, biochem, and psych-soc sections. So again, far less tested than some of the other skills, but still going to make up a section of each section of the MCAT. Some types of questions you could come across that have to do with skill number 4, reasoning about random systematic error, reasoning about statistical significance. So if you have significance levels, can you interpret a confidence interval? So if they give you the CI, if they give you a standard deviation, if they give you a mean, do you understand what each of those things means in isolation, but also within context of the whole research project? Also identifying correlations between demographic variables and life expectancy or another health outcome. So being able to see, okay, was this cause and effect or these just correlation? Can we create a cause and effect from a correlation? What is this correlation? Can I identify it? And there's always the question about, does the MCAT have math? Does it explicitly test math? And the answer is kind of. It tests your understanding. So half of it is asking to demonstrate your understanding. Within skill number 4, we were talking a little bit about analysis of data and statistical analysis specifically, but there are some other things that it is also testing within the ways that these SIRS questions may be presented to you. So for example, if you're given a table, that table may have some cosine values in it. It may give you a triangle and ask you certain things and just give you hints about certain angles. There are ways math is involved, but not in the explicit way of like needing a calculator. So you're going to have to demonstrate an understanding of exponentials, logarithms. So do you understand natural bases? Do you understand base 10, ln versus log, and the relationship of E with ln? Do you understand scientific notation? Do you understand how to like move the decimal over certain places based on scientific notation? Can you also solve simultaneous equations? All of this being at the algebra 2 level. And also all of these trigonomic concepts. So basic and inverse functions. So we got sine as well as inverse sine, cosine, inverse cosine, and then tan and inverse tan. The definitions of each of those. The values for sine and cosine for 0 degrees, 90 degrees, and 180 degrees. The relationships between the lengths of sides of special triangles of 30 degrees, 45 degrees, and 60 degrees. As well as vector addition and subtraction. You're not going to have to know dot products, cross products, but you are going to have to know a little bit about the right-hand rule when it comes to addition and subtraction of vectors. You're also going to have to know significant digits, estimation when performing measurements and calculations. So it's not about being able to use a calculator, type in some numbers and spit out a specific number and know that the number was correct or not, but it is about estimating correctly. So in going through the questions and eliminating incorrect ones, it's all about this is not a good estimate of what I think the answer should be to narrow down your answer choices. None of these talk about demonstrating an understanding of calculus. You don't understand how derivatives work in general or how integrals work. You have no questions that are going to explicitly be testing those concepts. But with most trigonometry stuff, most students are presented it with using a calculator. And on the MCAT, there's no calculator. So you are having to understand and memorize some of those things. But you're also going to have to recognize and interpret linear, semilog, and log scales, and calculate slopes from data found in figures, graphs, and tables. So there are some calculations that will be required of you without a calculator. So that goes back to where estimation is really more what they're testing, because if all of these questions are multiple choice, 3 of them are not going to be correct for some specific reason. So yes, you can get to the correct answer. You may not be able to estimate your way to the correct answer, but you can at least estimate and eliminate some incorrect answers. And from there, be able to get more of an approximation. You may have to do some calculations, but most of the things on the MCAT, if you find yourself taking too long doing a calculation, 1, there may be a shorter way to do it, but 2, that also just might not be a type of question for you to focus on and move on with your time and spend it elsewhere. You don't have to answer every single question correct in order to do well on the MCAT. You're also going to have to convert units within metric system and between English and metric units. So if you need conversion factors, those are always going to be provided. You don't have to memorize any of those conversion factors. They're always going to tell you how many pounds is in a kilogram, et cetera, if those types of conversions are going to be needed. But it is going to be expecting you to be able to convert units within the system. So if you have kilograms, do you know how to convert from kilograms to grams, et cetera, as well as dimensional analysis. And this is really where using units and canceling out units when balancing equations. So if you know PV equals nRT, okay, maybe you have that memorized. But if you don't and you know R, all of the units that they give you for R, which are like moles, temperature, pressure, and volume, then you can rearrange all of the other units of PV equals nRT to figure out what the actual equation should be. And so when it comes to memorizing equations, the MCAT rarely is testing explicit calculations of equations you have previously memorized. It's far more likely to be doing dimensional analysis. So using your units, balancing equations, they're going to give you a unit that you've never heard of, but they'll give you the derivative units. And so it's really more focusing how to cancel those things. So doing those conversions as needed. And also doing some type of arithmetic involving probability, proportions, ratios, percentages, and square root estimations. Again, none of these are going to be exact. All of these are going to be, can you estimate and get as close to the correct answer, eliminating incorrect answers along the way? And then from there, either guess or do a little bit of math to figure out which one is not the correct answer. So therefore, which one has to be the correct answer. None of the answer choices you will encounter on the MCAT are so close to one another that you will need a calculator in order to answer it. A calculator is not required, therefore a calculator is not required. Thanks for watching.